Let us now solve problem number 6, in which you need to find the simplest form of it. So here, first thing you need to observe is tan inverse. Therefore, you want this term in the form of tan function. So here, to solve further, you need to put value for x. So what value you can put for x so that the square root get cancelled out? So here, I'll put x as secant theta. Fine. So tan inverse 1 divided by root secant theta whole square minus 1. Tan inverse 1 divided by root secant theta whole square is nothing but secant square theta minus 1. So now if you observe this, what you can write in the place of secant square theta minus 1? So we know that secant square theta is tan square theta plus 1 or 1 plus tan square theta. And by shifting 1 to the LHS, here you'll get secant square theta minus 1 as tan square theta, right? Yeah, just to replace. Therefore, tan inverse 1 divided by root tan square theta. This is tan inverse 1 divided by, anyhow this square root and this 2 will get cancelled. Therefore, tan theta, right? Then tan inverse, this will be 1 by tan theta is nothing but cot theta, right? So now, instead tan theta, we have ended up with cot theta, right? While beginning the question, what I said, I want these terms in the form of tan. So still we are in some other format, right? So how to convert this cot theta to tan? So please do recall, you can write cot theta, that is nothing but tan 90 minus theta, right? 90 minus theta, that is nothing but pi by 2 minus theta. Fine, therefore, tan inverse of tan pi by 2 minus theta. So here, as I said already, tan inverse and tan are inverse to one another, therefore they cancel it out. Therefore, the remaining will be pi by 2 minus theta. So we know that x is secant theta, right? Therefore, you can write theta as secant inverse x. Just do replace, that is pi by 2 minus secant inverse x. So this is the simplest form of tan inverse 1 by root x square minus 1. So let us now solve 7th problem. It is also to find the simplest form of it. The first thing is to check this, then to get an idea about this, like how to convert and in which form to convert. So here it is tan inverse, therefore this should be in the form of tan function. Fine. So I'll tell you one thing, until you end up with the lesson, no, the tan inverse will not let you go anywhere. It will be behind you. So here you no need to put any of the x values. Okay, we can see, let us see how we can solve the problem. As I said, we want this to be in the form of tan function. So let's first calculate the value of 1 minus cos x and 1 plus cos x. So we know that, what we know? Must know each and every formulas of previous year. Fine. I hope you know. Cos 2x is 1 minus 2 sine square x. Now replace x by 2. Fine. So this gives you cos 2 x by 2 is equal to 1 minus 2 sine square x by 2. And here 2 and 2 get cancelled. Therefore, cos x is equal to 1 minus 2 sine square x by 2. Right? And what I'll do is just shift the terms. So you'll get 1 minus cos x is equal to 2 sine square x by 2. Consider it as equation number 1. Fine. Now, we know that cos 2x can also be written as 2 cos square x minus 1. Replace x by 2. Therefore, cos 2 into x by 2 is equal to 2 cos square x by 2 minus 1. This 2 and this 2 get cancelled. Therefore, cos x is equal to 2 cos square x by 2 minus 1. I'll shift 1 over here. Therefore, 1 plus cos x is equal to 2 cos square x by 2. Consider it as equation number 2. So you got 1 minus cos x and 1 plus cos x, right? So let us replace. Tan inverse root 1 minus cos x divided by 1 plus cos x is equal to tan inverse 1 minus cos x is nothing but equation number 1, that is 2 sine square x by 2. 1 plus cos x is nothing but equation number 2, that is 2 cos square x by 2, right? This 2 and this 2 get cancels. Fine. Okay. So this is tan inverse root, what is sine theta by cos theta? That is tan theta, right? Therefore, you can write sine square theta by cos square theta as tan square theta. Therefore, also you can write sine square x by 2 by cos square x by 2 as tan square x by 2, right? That is tan square x by 2. Now, this square root and this square and square root get cancels. Therefore, the remaining is tan inverse of tan x by 2. And here, tan inverse and tan are inverse to each other. Therefore, they cancel out. Therefore, you'll be ending with x by 2. So, x by 2 is the simplest form of tan inverse root 1 minus cos x by 1 plus cos x. Let us now solve problem number 8 to find the simplest form. Fine. So here you can observe tan inverse function, right? So therefore, you should get an idea that this term should be in terms of or in the form of tan function. So here, what we have to do is, we need to bring changes in the numerator as well as in the denominator. So how can you bring that change? So to bring a change, we should divide the whole equation by cos x. That is nothing but numerator by cos x, denominator by cos x. Shall do that. That is tan inverse cos x minus sin x divided by cos x divided by cos x plus sin x divided by cos x. Fine. Okay, now splitting out. So anyhow, this cos x which is there in the denominator, that will be splitted out to both the terms, right? So therefore, tan inverse of cos x by cos x minus sin x by cos x divided by cos x by cos x plus sin x by cos x. Now, tan inverse, what is cos x by cos x? That is nothing but 1. What is sin x by cos x? That is nothing but tan x divided by 1 plus tan x. So here, what we have to do is, we need to, so I can write this as 1 minus tan x divided by 1 plus 1 into tan x. So if 1 is multiplied to tan x, you will get tan x itself, right? No worries in it. So here, what I'll do is, I'll write 1 in terms of tan function. Why it is so? You'll get to know. Tan inverse, and the thing is, I write tan 1 as I have said, I'll write 1 as 1 in the form of tan function, right? That is only in certain place. Okay, I'll not write each and every one in terms of tan function. Wherever it is necessary, there only I'll write. You'll get to know why it is so. Fine. So how to write 1 in terms of tan function? We know that in tan 45 degree, that is nothing but tan pi by 4 is 1, right? Fine. So what I'll do is I'll change this 1 in the form of tan. Therefore, tan pi by 4 minus tan x divided by, I'll not change this 1 in terms of tan. Okay. So I'll keep 1 as it is. Plus, I'll change this 1 in terms of tan. That is tan pi by 4 into tan x. Fine. Now, why I have done all these things? This is because to adjust to certain formula. So if you observe this, you can be familiar to some formula. So what is tan minus y? What is tan of x minus y? That is nothing but tan x minus tan y divided by 1 plus tan x into tan y, right? So this formula is the main reason to bring changes in these terms. So using this formula, you can write tan pi by 4 minus tan x by 1 plus tan pi by 4 into tan x as tan pi by 4 minus x. Fine. So you know that tan inverse and tan are inverse to one another. Therefore, you will be ending up with pi by 4 minus x. So this is the simplest form of tan inverse of cos x minus sin x by cos x plus sin x. Let us now begin with the ninth problem, that is tan inverse x by root a square minus x square, where mod x is less than a. So here we want, okay, the first thing is we need to observe this tan inverse. Therefore, we want this term in the form of tan function. So we need to observe that, okay, this is a side point, an extra point you can say. So whenever there is root 1 minus x square in the denominator, I'm talking about especially in the denominator, whenever you find root 1 minus x square in the denominator, we put x as sine theta. Okay, we put x as sine theta. Why? Why? Because to get tan theta. Okay, we get, or not tan theta, to get a tan function. Okay, so whenever it is important, you can say it as a note. Fine. So whenever there is root 1 minus x square in the denominator, we need to put x as sine theta, so that you'll be end up with getting tan function. Fine. But here if you observe, you can see the presence of a. Therefore, what will be the value of x then? What you can put as x? So here we put x as a sine theta. X as a sine theta. This is mainly because to remove the square root. Fine? Okay. So here, therefore, tan inverse x as sine theta, right? Divided by root a square minus x is nothing but a sine theta. Therefore, a sine theta whole square. So this will be tan inverse a sine theta divided by root a square minus a square sine square theta. Right? The square is applied for a as well as sine theta. So then tan inverse a sine theta divided by root. Now what I'll do is I'll take a square common in the denominator inside the square root. That is a square. Remaining is 1 minus sine square theta. Right? So here this will be tan inverse a sine theta divided by root a square into root 1 minus sine square theta. So this will be tan inverse a sine theta divided by square root it cancels. Okay, therefore this will be a root 1 minus sine square theta. So now how can you bring this term in the form of tan? So we know that, what you know, that is sine square theta plus cos square theta is equal to 1. Therefore you can write 1 minus sine square theta as cos square theta. So in the denominator you can see the changes, right? So this will be, okay, before that we shall deal with a. Let us cancel it out, a and a. Fine, therefore tan inverse sine theta divided by root 1 minus sine square theta is nothing but cos square theta. Fine, so this will be tan inverse sine theta by square root, square and get cancels, right? Therefore remaining will be cos theta. Therefore what is cos theta, sine theta by cos theta? That is tan theta. Now tan inverse, tan are inverse to each other, therefore they cancel out, therefore the remaining is theta. So what is theta now? So we know that, or we have taken x as a sine theta, right? So now we want theta, therefore you just bring a to the denominator first, that is x by a is equal to sine theta, right? Now you'll get theta. Theta is sine inverse x by a. Fine? Yes. So this is sine inverse x by a. So sine inverse x by a is the simplest form of tan inverse x by root a square minus x square. So 10th problem. Tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. So here again tan inverse, therefore we want this term in the form of tan, right? So what will be the value of x now? You can see a also, right? So should not neglect a. Fine, a will help you. Therefore you should include a while considering the value of x. Therefore I'll put x as a tan theta. So therefore tan inverse 3a square, x is nothing but a tan theta, right? Minus a tan theta whole cube divided by a cube minus 3a x square, that is nothing but a tan theta whole square. Just go on solving this. That is tan inverse 3, just multiply this will be, therefore a cube tan theta minus, so cube is for both a and tan theta, fine, therefore a cube tan cube theta divided by a cube minus 3. Here you can observe that square is applied for both a and tan square theta, therefore outside there is one a already, therefore you'll get a cube, right? So first open up the bracket, then multiply the term, but I have written directly, no issues on that. Tan square theta, so this is tan inverse, so here from the numerator I'll take a cube common, a cube 3 tan theta minus tan cube theta divided by, from the denominator I'll take a cube as well, therefore 1 minus 3 tan square theta. So now I'll cancel out a cube both in the numerator and denominator. Therefore, you will be with 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Now, just recall the formula. What is tan 3 theta? Tan 3 theta is nothing but 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So, you got the answer. Tan inverse of tan 3 theta. So now, this is simply 3 theta. What is theta now? X you have taken as a tan theta, right? Therefore, x by a is equal to tan theta. Therefore, theta will be tan inverse x by a. Tan inverse x by a. So, this will be 3 tan inverse x by a. So 3 tan inverse x by a is the simplest form of tan inverse of 3a square x minus x cube by a cube minus 3a x square. Let us now solve problem number 11. Here you need to find the value of tan inverse of 2 cos of 2 sin inverse 1 by 2. First we shall solve sin inverse 1 by 2. That is, we need to find the principal value of sin inverse 1 by 2. For that, we need to assume sin inverse 1 by 2 as y. Fine. Let us first consider this as equation number 1. So as I said, we need to find the principal value of sin inverse 1 by 2. So you know already we have solved few problems based on principal value, right? So first thing, we need to assume sin inverse 1 by 2 as y. Therefore, you will get 1 by 2 as sin y. Now, I want 1 by 2 in the form of sine function. So, we know that, what we know? We know that sine 30 degree is 1 by 2, right? That is nothing but sine pi by 6 is 1 by 2. Therefore, 1 by 2 can be replaced by sin pi by 6 is equal to sin y. Therefore, this implies y is equal to pi by 6. Now, we know what is y. That is sin inverse 1 by 2, right? Therefore, this implies sin inverse 1 by 2 is equal to pi by 6. This is nothing but pi by 2 is the principal value of sin inverse 1 by 2. That's it. Fine. Now, let us use this in equation number 1. So, what is equation number 1? Tan inverse 2 cos 2 sin inverse 1 by 2, right? So, equation number 1, by replacing sin inverse 1 by 2 by pi by 6, equation number 1 implies 2 cos 2 into sin inverse 1 by 2 is nothing but pi by 6. So now tan inverse 2 cos, here 2 ones are 2 threes are, therefore cos pi by 3. Now what is cos pi by 3? Cos pi by 3 is nothing but cos pi by 3 is 1 by 2, right? Therefore, 2 into 1 by 2. So, this and this get cancels. And here, tan inverse of 1. Now, I want 1 in terms of tan. Why it is so? It is only because to get a certain answer, right? Fine. So, here we know that 1 can be, how to write 1 in terms of tan? That is nothing but 1 is tan pi by 4, right? 1 will be, so you can write 1 in terms of tan by tan pi by 4. Therefore, tan inverse tan pi by 4. This is simply pi by 4. So pi by 4 is the value of tan inverse of 2 cos of 2 sin inverse 1 by 2. Let us now find the value of cot of tan inverse A plus cot inverse A. Please recall property number 4. What is property number 4 says? That is tan inverse x plus cot inverse x is equal to pi by 2. So apply the same logic over here. That is cot of pi by 2. I'll just replace tan inverse A plus cot inverse A by pi by 2. So here cot pi is nothing but 180 degree, right? Pi in terms of degree I am talking about. Okay, that is 180 degree by 2. So cot, this will be 90 degree. Fine. So what is cot 90 degree? Cot 90 degree is 0. So 0 is the value of cot of tan inverse A plus cot inverse A. Easy, no? Let us now solve question number 13, in which you need to find the value of tan 1 by 2 of sin inverse 2x by 1 plus x square plus cos inverse 1 minus y square by 1 plus x square, where mod x is less than 1 and y is greater than 0 and xy is less than 1. So here first thing is to notice this term. So here there is tan, therefore you need to convert this term in the form of tan inverse. Okay, so the thing is alternative. Whenever there is tan inverse, you need to convert this term in the form of tan function, and whenever here there is tan, you need to convert this term in the form of tan inverse. Fine. So to solve this, what I'll do is I'll calculate cos inverse and sin inverse separately. So here let us solve first sin inverse 2x by 1 plus x square. So here I'll put x as tan theta. Fine. Therefore you'll get sin inverse 2 tan theta by 1 plus tan square theta. So this is sin inverse 2 tan theta by 1 plus tan square theta is nothing but secant square theta, right? So then sin inverse 2 tan theta can be written as sin theta by cos theta divided by secant square theta is nothing but 1 by cos square theta. So then sin inverse 2 sin theta by cos theta, and if you write the denominator over here, that is cos square theta by 1, right? Then this will be, this cos theta and this 1 cos theta will be cancelled. Therefore sin inverse 2 sin theta into cos theta. So you know that 2 sin theta cos theta can be written as sin inverse of sin 2 theta. So here you need to recall the formulas of previous year, or you need to recall the formulas that you have learned till now. So because whenever you solve the problems under the inverse trigonometric functions, you need to recall each and every formulas, because that plays an important role. If you forget or if you don't know, you cannot move further. So please study or recall each and every time whenever you are free or whenever you solve these kind of problems. So this will be simply 2 theta, right? Fine. Let us now solve cos inverse 1 minus y square by 1 plus y square. So here I'll put y as tan alpha. Fine. So this will be cos inverse 1 minus tan square alpha. Tan alpha whole square is nothing but tan square alpha. 1 plus tan square alpha. Right? Okay. Now, cos inverse 1 minus tan square alpha divided by 1 plus tan square alpha can be written as secant square alpha. So now cos inverse 1 minus tan square alpha is nothing but sin square alpha by cos square alpha divided by 1 by cos square alpha. So just converting them, that's it. Okay. Then cos inverse, cross multiply, cos square alpha by minus sin square alpha by cos square alpha into cos square alpha by 1. So here this and this get cancelled. Therefore cos inverse of cos square alpha minus sin square alpha. This is the term which is remaining now. Now if you observe this, you can write it as cos inverse of cos 2 alpha. Therefore this is simply 2 alpha. We have calculated sin inverse 2x by 1 plus x square and cos inverse 1 minus y square by 1 plus y square. Now just replace 2 theta and 2 alpha in the place of those terms. So here, if you consider this as equation number 1, if you consider question as equation number 1, then the question, that is equation number 1, implies tan 1 by 2 theta plus 2 alpha. So here tan 1 by 2, you take 2 common or 2 outside, that is theta plus alpha. Therefore this 2 and this 2 get cancelled. Therefore tan theta plus alpha. So what is tan x plus y? That is nothing but tan x plus tan y divided by 1 minus tan x into tan y, right? So similar, so same thing, same logic is applied over here. That is tan theta plus tan alpha divided by 1 minus tan theta into tan alpha, right? Now we know what is tan theta and tan alpha, right? So tan theta is x and tan alpha is y. Just do replace. Okay, so here tan theta is x and tan alpha is y, that we have taken while solving in the beginning, right? So here x plus y divided by 1 minus x into y. So this is the value of tan alpha. This is the value of tan 1 by 2 of sin inverse 2x by 1 plus x squared plus cos inverse of 1 minus y squared by 1 plus y squared. Let us now solve problem number 14, in which you need to find the value of x. The given question is sin inverse 1 by 5 plus cos inverse x is equal to 1. So how to find the value of x? So before solving the question, let us consider the given question as equation number 1. So first let us concentrate on this one, the one which is present in the RHS. Let us concentrate on that first. So we know that sin 90 degree is 1, right? That is nothing but sin pi by 2, right? Pi by 2 is 1. Let it be equation number 2. Now what I'll do is, I'll just compare equation number 1 and 2. Compare equation number 1 and 2. So that sin inverse 1 by 5 plus cos inverse x is equal to sin pi by 2. So on comparing equation number 1 and 2, you'll get this. Now what I'll do is, I'll shift this sign towards the RHS. So you know that whenever the sine function crosses the equals, it becomes inverse, right? So this will be sine inverse 1 by 5 plus cos inverse x is equal to, so this sign has been crossed the equals, therefore this will be sine inverse of sine pi by 2. Now sine inverse 1 by 5 plus cos inverse x is equal to, sine inverse of sine pi by 2 is simply pi by 2. Now, if you observe this, so please recall the property that says cos, please recall the property that says sine inverse x plus cos inverse x is equal to pi by 2, right? So here sine inverse x can be written as pi by 2 minus cos inverse x, right? Therefore, you can write sine inverse 1 by 5 as pi by 2 minus cos inverse x. What I have done is I have just shifted cos inverse x. See, I am shifting cos inverse, the entire term. Okay, the entire term is shift towards the RHS. Okay, not only cos inverse. When only the cos inverse is shifted to right side, it becomes cos. But when the whole term is shifted, it becomes minus cos inverse x. Fine, don't get confused. Fine. Now, so we know that pi by 2 minus cos inverse x can be written as sine inverse x, right? Therefore, sine inverse 1 by 5 is equal to, I'll replace this by sine inverse x. So now what you will do? So this is nothing but x is equal to 1 by 5. Fine. So here the value of x is 1 by 5. So we have found the value of x.